Today I'm going to tell you the most important things you need to know about energy efficiency. Energy efficiency means providing the same or better service using less energy. It is not the same as energy conservation. Energy conservation is doing without the service. So that's changing your thermostat to a lower temperature in the winter or something. So putting on a sweater, that's energy conservation. Energy efficiency, you're still getting the same or better service. We put energy efficiency as a renewable resource and actually kind of the ultimate renewable resource. We can always do more and better as we figure out new strategies, new software and optimization, new hardware. We can continue to provide services we want using less energy. And a lot of studies have shown the huge benefits for energy efficiency. This is a very famous greenhouse gas abatement curve that was developed by McKinsey and Group, looking at what are the cost of different options, whether they're net positive or not, whether basically you have cost savings over the lifetime of that implementation, and how much carbon benefit do you get from implementing that option? And many of these, you see them in the grayed area here on this chart. Many of these are energy efficiency measures that actually save money because even if you have a higher capital investment up front, sometimes it's the same, sometimes it's more, you save energy over time. And so the overall project actually has lower costs than not implementing that energy efficiency measure. And we've been doing energy efficiency for a long time. Here I'm showing the energy consumption in the United States over time since the mid-1970s, which is a key date because in the 1970s is when we had the Arab oil embargo and really saw shortages of oil and really had this kind of awakening of how dependent our economy was on imported oil. And that really brought an awareness about energy efficiency and many of our energy efficiency policies, both in transportation and in buildings and in other areas, were implemented following that Arab oil embargo. So what this chart is showing you is we thought we were going to be using over double the amount of energy today in order to meet our needs than we actually are today. The world, in terms of its energy efficiency, has huge opportunities. What I'm showing you here is the world energy flow to really give you a sense of how much energy we're actually losing in this system. This is our rejected energy. This is stuff that's not providing energy services. And so you can see that for the world overall, the energy efficiency of the global economy is only about 40%. So 60% of the energy that we're mining for, or we're drilling for, or producing is just being rejected. So if we can do this better, we can provide more energy services with less impact. One of the big opportunities for energy efficiency is looking at where we're using our energy. So just as an example, if we're thinking about where our electricity is being used worldwide, electric motor-driven systems consume more than any other end use in the world for electricity. And so what are electric motor-driven systems? What does that mean? I've put some examples down here. All of these are driven by electric motor-driven systems. And so that's just one place that we have an opportunity to do savings. If you've ever seen a piping system around a building, around industry, around your house, we often use right angles for our piping system. It's easier to think about, it's easier to lay out, but it leads to a lot of friction and a lot of loss when you're trying to make those fluids turn a corner. And so just by designing low friction systems that instead of having things meet at a right angle, they meet at a Y, you can have a lot less electricity demand for that same flow rate. You can reduce the size of your piping systems. You can reduce your pumping size. So again, this is just about doing it smarter in order to save energy. And just wanted to give an example. Our blood system is a pumping system with our heart. None of our blood vessels meet at right angles. They all meet at T's. They all Y off. They're not meeting at right angles like a T. And so that is a very efficient system. And we're not quite there yet in our industrial systems, but this is one example of biomimicry, which is a way that nature shows us ways that we can actually improve our energy systems. Lighting comes up a lot. It's kind of two different things to think about of lighting. Daylighting is a huge one. Even Walmart did a study and found that daylit areas actually get higher sales. So all their new builds are including skylights for targeted daylighting. And LEDs have been a huge revolution in lighting where we're getting a better service because LEDs can really be tuned to all sorts of different colors that you need. They don't give off heat, so you don't have to have cooling measures to offset the heating of the bulb, and they last longer, so maintenance costs are also lower with LEDs. All of that means energy and cost savings, and the US DOE says for LEDs just in the United States, by 2035, we'll have saved the equivalent of the output of 92 1 gigawatt power plants. So that's like 92 nuclear sized power plants we didn't have to build in order to provide this lighting service. That's the magic of energy efficiency. And electrification is one of the big trends that's happening right now that is really improving efficiency and decarbonizing a lot of our services. So I put two of the big ones here. Electric vehicles are 3 to 4 times more efficient than their gasoline counterparts. Heat pumps, 300 to 400% efficient, which sounds magical, but a heat pump is actually providing a heating and cooling service by moving heat rather than creating it, which is why you get that 300 to 400% efficient compared to our other heaters like natural gas furnaces or electric heaters, both of which are pretty efficient, but never going to match the efficiency of a heat pump. So we're seeing heat pumps growing both in the United States and in places like Europe. And it's not just hardware that we have energy efficiency going on. We optimize operations, and AI is giving us opportunities to optimize operations even more. Just to give an example is think about a delivery service organization, kind of like think about an Amazon. They want to optimize the delivery and transportation of goods because it lowers their fuel costs. It lowers their energy needs. And so if they can optimize how they're doing their deliveries, they can not only provide a service that uses less energy, but probably gives you a more timely and more effective delivery service. And so this is just an example that operations can be really important too in lowering our energy use while providing the same or better services. Now, I've just given you kind of a laundry list of some exciting things going on in energy efficiency, but if you're really going to think about how to really decarbonize and get lower energy systems to provide services we want, one of the best tools for that is something called integrative design. And if this is something you're interested in, I encourage you to go over to our sister hub, efficiencyhub.stanford.edu, to learn more about integrative design. This is an approach that looks at what are the services we're trying to provide and how can we provide those services in the best way. So we're often getting a better service and using less energy in the process. It is really looking at the whole system and not just individual measures like I was just kind of going through. All right, so that's all the kind of like the good news about energy efficiency. There are barriers to energy efficiency. And so I've listed some of the key ones here. Oftentimes you have upfront costs because the savings accrue over time. Split incentives is a big one. I'll talk about that more in a minute. And just lack of information education. We have to have education in order to transition to some of the latest technologies that bring some of these energy efficiency benefits. Split incentives is a big one. And just to give a really common example, split incentive is where one entity is having to pay the cost and another entity is getting the benefit. So a traditional example of this, landlords, whoever owns the building has to pay for the capital investment to install the energy efficiency measures. But whoever is leasing or renting that property are the ones that are paying the energy bill and actually reap the energy savings. And so without other policies, a landlord would not be incentivized to pay for the upgrades that their tenants are going to benefit from. There are a lot of different ways to approach this and try to overcome some of these split incentives. I list one here in these pictures. New York City has a program where buildings are actually rated for their energy efficiency. What this does is it allows like renters to assess the energy efficiency of a building that they're going to rent and provide some incentive for landlords to kind of compete against their neighbors because their consumers are informed about the energy efficiency of their property. So this is like a benefit for consumers, they're informed, and it is an incentive for landlords to make those investments. So there's a lot of different policy measures that can really kind of address some of these barriers. Sometimes it is just setting standards. And we've seen a lot of success actually in setting standards, which is just you have to meet a baseline energy efficiency standard in order to drive innovation in different consumer products or buildings or things like that. So just kind of one really successful example is talking about refrigerators. So I mentioned a lot of policies went in place in the 1970s. This one also went into place. California kind of led the way and they said, hey, we're going to require refrigerators meet a certain energy efficiency standard, and then they continue to ratchet that down over time. And so what I'm showing you is that when these standards were put in place and the energy use of our refrigerators, how it continued to go down, 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 the price actually also went down. Everybody in the market had to meet these standards and they were still competing on price. And the size has actually gone up over that same amount of time. So you're getting a better service, costs have declined, refrigerators use less energy. And so what we're really seeing is a typical new refrigerator uses a quarter of the energy while offering 20% more storage capacity and selling at half the retail cost. It's really successful, but somebody had to drive it so that the whole industry had to meet those standards. Another program that's been really successful, this is more about information and education and awareness, has been the U.S. Energy Star program. It is one of the most recognized and trusted labels by consumers in the United States. So it's been a very successful program. This program has been in place for a long time. It is not currently in the budget. So the budget has been removed for Energy Star under the proposal in the United States. We kind of have to see what the future of this program will be. Finally, just another big example on policy. Building energy efficiency codes can be very important for driving the building industry towards more efficient buildings. One of the things that can be really challenging with energy efficiency is implementation of new systems, new technologies, new designs, because the industry tends to be more conservative about taking risks. So having policy that pairs with technology that's been proven and continues to ratchet down energy efficiency codes can really be important for driving energy efficiency in our buildings and making more comfortable, more enjoyable buildings. Finally, for really thinking about the future of a decarbonized energy system that really provides energy services for all, we have to be thinking about energy efficiency. It is a key component of our strategy. If we can provide energy services using less energy, it is easier to provide services for more people, and it is easier to decarbonize our energy systems. So energy efficiency really is a very important piece of all of these efforts. Okay, that's what I have for you guys about energy efficiency today. If you want to learn more about it, check out our full lecture. We also just did an energy spotlight on energy efficiency, showcasing some other examples of biomimicry you can see in this picture where we're learning from nature.